Hello everyone, myself Dipti Gusse as Assistant Professor in School of Computer Engineering at MIT Academy of Engineering, Alandi, Pune. Today's our discussion topic is object detection using YOLO model. Now let us discuss about the object detection. Now object detection is a technique used in computer vision for identification and localization of object within an image or an video. Nowadays there are a lot of video images are available in online or live images, live videos are there. Now here whenever image consists of multiple objects one in one image, at that time CNN is not able to classify or detect the object in an image. For that we require the another deep learning algorithm for the object detection. Image localization is a process of identifying the correct location of one object or multiple objects using bounding boxes. These bounding boxes which correspond to the rectangular shape around the object, which will cover the complete object with respect to the content in that image. This process is sometimes confused with the image classification or image recognition, which aims to predict the class of image or an object within an image into one of the categories or classes. Now let us consider this image. Now in this image you can see this is the image. In this image only one object is there, that is a cat. Now here we are this is the case example of classification. Now here we are classifying image which consists of only one object, and here we are localizing the object in image. Next, object detection. Now in object detection, in this example there are multiple animals objects are there. These are the cat, dog and duck. These are the different animals in an image. Now here we can also apply instance segmentation for the multiple object detection in image. Here one more example, the image recognition. Now here we are recognizing this is the person, but before that we need to add the bounding box over the image, that is the localization, image detection, recognition and localization. Now here this image object detection using the YOLO model we can implement in deep learning. Now what is the YOLO? YOLO is you only look once. That is, YOLO is a state-of-art real-time object detection algorithm introduced in 2015 as Joseph Redmond and Santosh Devla and Ross. And this they have published and demonstrated their work from the famous research work that you only look once, the unified real-time object detection. They have these author they have framed the object detection problem for regression problem instead of classification task by specially separating bounding box and associating probability in each of detected images using single convolutional neural network. Now here whenever we are using this YOLO model, that in YOLO model we are doing two tasks. One is a regression and another is classification. Using regression we can recognize that in that particular bounding box the object, how this object is covered, and using classification whatever object detected and localized in bounding box, that object will be classified into respective class. Now let us discuss how this YOLO model is different. This unification of all independent tasks into one network has following benefit. Now here speed. Now with respect to the other object detection algorithm like RCNN or faster RCNN, the YOLO will give the better result in terms of accuracy, speed and background with less background mistake and highly generalizable. YOLO is extremely fast compared to the predecessor and single convolution network to detect the object. Now convolution will work for the entire input image only once to yield the prediction. Less background mistake whenever we are detecting the object in using YOLO. At that time maximum part of the background will be removed and only it will be focused on selected or region. Next, highly generalizable. YOLO learns the generalizable representation of object, due to which it can be applied new domain and unexpected input without breaking. Now let us discuss the basic architecture of YOLO model. In YOLO model there are three main pieces. First one is the backbone, second one is the neck and third one is head. In backbone, now here in backbone the actual convolutional neural network that combines and forms an image feature in different granularity. that is a backbone. Now using CNN, this is the input image using backbone, that is a convolutional neural network, aggregates the features and display the features at different scale or granularity. Now means we are selecting that, extracting the features of the images at the different abstraction level. Next one is a deck, that is a series of layers to mix the combine the features. Now whatever features extracted in using the backbone, these features will be combined to pass them forward for the prediction. And last one is the head piece that consume the features from the neck and take the box and class for the class prediction step. That step, last step is a head step. Actually this YOLO model work in two-stage detector. Now in one-stage detector up to prediction, and in sparse detection we are detecting the object as well as performing the classification. Now this is the YOLO architecture. Nowadays again there are different n number of YOLO versions are available. Now recently we are YOLO 11 is there available. Now this version give the progressively they are improving their accuracy for the object detection in image as well as in video. Now here this is the similar to the convolutional neural network. There are n number of convolution layers are there, followed by the ReLU, activation, pooling layer, and at the end bounding box will be drawn across the multiple objects in an image and perform the classification. Now YOLO network split the image into grid S by S. Now let us consider one single image, it will be split into grid S by S. If center of the ground truth box falls into cell, that cell is responsible for detecting the existence of that object. Means that in that particular box that object is detecting, based on the we are comparing that grid with our ground box image. If it is available, it means that object is detecting the existence of that object. Each grid cell predict the B number of bounding boxes and their objectness score. Objectness score means that particular object cover in that bounding box with their class prediction. The coordinates of the bounding box. Now here main thing, that is what are the coordinates of the bounding box. The YOLO predict 4 coordinates bx, by, bw and bh with respect to the corresponding cell grid. This bx and by are x and y coordinates of the midpoint of the object with respect to the grid. Now here in this let us discuss one example. Now in this example here this is the bounding box. Okay, now here there are different values are there, bx, by, bx, by. This is the center point. This is the center point of bounding box. Height bh and bw. This is the height and width of the bounding box. Okay, and here p and pc means the availability of that particular model. That is the class of that particular model. And C, whether that object present. That's value C is corresponding the class of object, whether it is car or traffic light. Okay, now these are the parameters we are using in a YOLO model. Now what are the key features of YOLO architecture? There are two key features of the YOLO model. First one is the anchor box and second one is the non-maximum suppression, that is a NMS. In advanced version of the YOLO introduced one anchor boxes concept. These are the predefined the bounding box shape and to better predict the multiple object varying the shell within the grid cell. The non-maximum suppression uses means here whenever you are training our model, the multiple boxes will be drawn, and here but see these all multiple boxes are covered. There is a probability to cover the maximum objects, but here for one object there may be chances of multiple boxes. So in this case we need to select the bounding box whose confidence score is more for that detected object. Based on this we can filter out these bounding boxes, overlapping bounding boxes, keeping only the box with highest confidence score for each detected object. Now let us discuss one example. Now in this example you can see this is the image classification and this is object localization. Okay, is this dog or person? Now this is the dog or person. Now dog for dog 1 value and for person 0. Now here drawing the bounding box. Okay, now here we are recognizing this is the dog is equal to 1 and bounding box. Okay, also drawing the bounding box, that is the localization and also perform the classification. Okay, whenever we are implementing this YOLO example or object detection algorithm, we need to use the data set which consists the label in this format for the ground truth images or videos. Now this is the X-train and this is the Y-train data set. Now in X-train data set there are 3 images. Now for this image, the input image in training data set will be available in this format. This is the bounding box. Okay, now these are the dimension. Now bx and by represent the bonding center of the bonding box. W and h represent the width and height of the bonding box, and there are 2 more parameters, c1 and c2. Now here we are doing the classification for against 2 classes, that is a dog class and person class. So here there are 2 classes. Suppose there are 5 classes, then c1, c2, c3, c4 up to c5. 5 classes will be there. If that object belongs to that particular class, then that value represented by 1. Okay, yes, now c1 represent with respect to the dog class. So here in ground truth label, the value c1 is equal to 1. Okay. Now here PC represent the multiple number of objects in an image. Now here only one object is localized in this image, so PC is equal to 1. Now in this way we are passing the data set, and these images will be passed through the convolution neural network for extracting the features. Now here one more example. Now here this is the only one image, the bond. These are the dimension of the bounding box. This is the dog this image bounding box object belongs to dog class and 0 for human class. Okay, the image which consists of the multiple object. In this way we can represent the ground truth label. Now here no object, here there is one object. Okay, here in YOLO model, the key feature, that is a non-maximum suppression. Whenever we are implementing YOLO model, at that time here there is a chances of drawing multiple boxes. Okay, now here after applying the non-maximum suppression, we are filtering this bounding box and selecting the bounding box, the suitable bounding box which will cover the maximum appearance of that particular object. Okay, now there are different number of evolution of YOLO model, like YOLO 1, 2, 3, based on the features, based on the accuracy. These models are progressively updated by the different researchers and authors. Okay, this is all about the YOLO model. In next video, we'll discuss about implementation of YOLO model using pre-trained model. Thank you.